Okay? So, let's, oh my, where are all the people?
Well, Olivia's at the matinee.
Yeah, I knew that.
Oh,
She
there's a field
communicated
trip
with
today.
me.
There's a field trip for class, like a sports science class.
Gary's probably in the matinee.
I don't think she is. She might be sick. Yeah.
And Daniel, they might be on that field trip. We're missing. All right.
Yeah.
So, anybody see something on a homework that you want to talk about? Now's the time. Anything I marked wrong, you're sure you're right, or you have no idea how you went wrong? Let's talk about it. Oh, you have the whole back row's hands up. Yay! Luke, we'll go with you first.
Yeah. 2.5, 3B.
2.5, 3B.
Yeah.
Okay. So we need, this is something we definitely need to have figured out. So here we go. We have just a table of values. And the directions say, it's exponential. For each, find the constant value that can be added, subtracted to the outputs to reveal a proportional growth pattern, then write an equation to model the function. So your equation, it's an exponential model, but there's something that's been added or subtracted to it. That's what these directions mean. Does that make sense to you? Okay. So the first thing I'm going to do is take a look at my differences. I'm kind of programmed to do that. So -1, what is that, 1.5? I'm subtracting. 5, that's 6. That's 24. And this is, I don't know, what is that? 96, okay. Now, take a look at these numbers. What is happening to these differences? They are being multiplied by 4. So your proportion, your ratio, your base is 4. Does that make sense to everybody? Okay, so now I know my equation is 4a times 4 to the x plus c. This is my equation. So I'm going to pick an ordered pair. I don't know, we could use the first one. And I'm going to plug it in. So -2.5 equals a times 4 to the 0 plus c. Does that make sense to you? We're cleaning that up a little bit. Doesn't that just say that -2.5 equals a plus c because this is just 1? And then I might as well, I'll just use the next point. I can use whatever points I want. Oh, maybe the next one would be, give me a, it's fine, I'll use the next one. So 1 equals a times 4 to the first plus c. And my second one, any of these points could be used. I'm just using the first two. So this says -1 equals 4a plus c. So what have I got here? What have I got when I do that? A system of equations that's actually lined up perfectly to eliminate the c's. Let's get those c's out of there. So when I add, I get 1.5 equals 3a. So a equals 1.5 divided by 3, is that 1/2? So now I know my A is 1/2. And I need to find my C, I'll go back to one of my equations here. -1 equals 4a's plus c. So -1 equals 2 plus c. It looks like c is -3. So my equation is 1/2, no, yeah, 1/2 times 4 to the x minus 3. Is that okay? All right, who else has a question? That was all one problem, that's a lot. All right, who else has a question about something? Yes, Joe,
5B.
on that same paper,
Yes, 2.5.
5B.
And A, go A and then 2Y.
Okay,
5.
5.
There's A.
The amount of money in an account paying interest, which is compounded continuously, is given by a formula that you know. I wrote it down, but you know. T is in years. How much money will be in my account after 10 years if I make a one-time deposit of $92 at 3.2% interest compounded continuously? So just plugging and chugging. My principal, that's my initial amount, my initial investment is $92. My interest rate is 0.032. And 10 years, so T is 10. So I'm just gonna type it in on my calculator. So 92. I got $126.70. Okay, Joe, does that make sense to you?
Yeah.
All right. Now, when will the account have more than $920?
Yeah.
Well, you've got an option, a couple of options here. What are our options? What's one option?
Set it equal to 920.
Okay, so if I do that, remember I'm solving for T or X, whatever you wanna call it, I'm solving for that. So if I do it this way, then I'm gonna divide both sides by 2, so that works out great, so I have 10. Now, because the variable is an exponent, and there's no common base between 10 and e, I'm gonna have to use logarithms.
Yeah.
So because there's an e in the problem, I think I'll just ln both sides. Remember, ln e cancels their inverses. So ln 10 is 0.032t. So one option is just to take out your trusty calculator and calculate for both options. Just do that division. So ln 10 divided by 0.032, I got 71.95556 here. Okay, what's the other option? This is fine, and by the end of Unit 2, you will have to do your problems this way, or be able to do them this way. What's the other option, though, that you could do without needing logarithms? We could graph it. So we could graph this right here. Actually, what I would probably do to keep the numbers a little smaller is I'd go ahead and divide by 92 and have this. And this as one equation and this as another, and see what it does. Okay?
Do you get the same answer if you do log instead of?
Absolutely. Absolutely. If you do logs, actually, Raina, because this is a 10, if you did log both sides, this will cancel and just make 1. This actually cancels. You don't need to know that right now, but so either way, because that's a 10, which is log base, and this is an e, which is ln base, one side or the other is going to cancel out when you do it. But yes, you should have gotten the same answer.
I did.
Yeah, absolutely. The base you use doesn't matter. You could even log base 7. That's hard, but you could do that and get the same answer. All right, anybody else? Yep,
Can you do 1A on 2.5?
2.5. 1A. Now this is without our calculator, which we did, that one I just erased over there, we did that without a calculator too. But here the numbers are a lot easier. Okay, so write the equation of the exponential function. Okay, Lily? All right, so what do you think we ought to do first? Huh? Oh no, we need to know what to do first. Can someone help her? Julia?
Take one of the orders and plug it in the equation.
Yeah, and I would suggest if you got one that's a 0, plug that one in first. So I'm just gonna plug that in. So 16 equals A times B to the 0. What is the good news about that? We know what A equals, so A equals 16. Remember, in an exponential, A represents your initial value. Look over here. This guy, this number in this position represented how much money I started with. That's your initial value. Your initial value is your y-intercept times 0. So yeah, 16 is A. Then take your other point and plug it in. So 54 equals 16 times B to the 3rd. Oh. So I don't know, what's 54 divided by 16? That's what I have to do first. That reduces somehow, doesn't it? 2 is what, 27/8? So B cubed equals 27/8. So B is 3/2. And your equation is y equals 16 times 3/2 to the x. Now, if this 0 had not been there, then this would not have happened. And I would have been left with 2 equations and had to do substitution or elimination. But because that one worked out so nice, I didn't have to. Okay, anything else? Yep.
Number 4 on 2.5.
Number 4 on 2.5. Remember, bacteria in a certain culture can be modeled by this equation. So it's basically the same equation I'm erasing there. So the bacteria in the culture is 170 e to the 0.02. So the T is in hours. All right, find an equivalent expression of the form A times B to the x. So we've done lots of this, so I'm glad that you asked about this, because this is important. So an equivalent equation, I'll call it something else. Did they tell me to call it something else? F of x. So f of x. This right here can be calculated as a decimal. So what is that? E to the 0.02 power is 1.0202 to the t. So you see what I did there, Riley? Okay. Now, what's the benefit of that? Well, when they give me this, I don't really know. I can see this thing's growing, but I don't really know how it's growing. When I write it this way, I can see it's 2% per hour. That it's increasing. So that's the equivalent. Find the average rate of change of this thing over the interval from 2 hours to 6 hours. Guys, average rate of change. Oh my gosh, we've been doing that since day 1, it seems like. How do you find the average rate of change? You take the function value of the second input minus the function value of the first input and divide it by the difference of the inputs. So I'm gonna take out my calculator, I'm gonna figure this by plugging 6 in right there. I'm gonna figure this by plugging 2 in right there, subtract those and divide by 4. I'm gonna try to do this without, round off error. Let's see, 170, second ln, 6 minus 170, second ln.
That pound.
And then divide that by 4.
Yeah, one second.
Okay, so what did I came up with? 3.684. It's a rate of change in a context. So what's the unit on it? That's 3.684 watts.
Bacteria per hour.
Bacteria per hour. Okay? And then find the times when the number of bacteria is 1, 2, 3, 4. So what do I do about that? We just talked about a problem like this. What do I do? Equal to, so 1, 2, 3, 4 equals 170 e to the 0.02 t. And then I have a choice. I can either graph each side and see where they cross, or I can use logarithms. I'm gonna run through that real quick because we need to know how to do it. If I'm going to use logarithms, what do I have to do first? Divide. And there is no point in actually doing the division. You're gonna go to your calculator in a second, so just leave it like that. Now, what happens next? Since my variable is an exponent, and there cannot be a common base, the only way to solve the equation algebraically is to use logs. So I'm going to ln or log, it doesn't matter, whatever flips your switch. I like the ln because that's gone. So the natural logarithm of this is going to equal 0.022. So t is going to be the natural logarithm of this divided by 0.02. And now I can just go to my calculator and type it in. And I got 99.111, and that would be hours. Okay? Now, one thing that was fascinating as I graded some of these papers is, and you're all good students and you want to do your assignments, but like, if you answered this question with negative 8.73, something should have gone off in your head like, oh, that's not right. Or like, there was a squirrel problem, and I got negative answer. You can't have negative squirrels. Those things should click into your brain. So try to be engaged as you're doing the homework so that you pick up when you make those kinds of mistakes. All right, that's enough for now. Let's take a look at, in your notes packet, yesterday we did the one that review that had the boxes. Now we're going to just do the review that has the problems. Okay? All right? So let's run through a few of these, we'll do a few together, see if there's anything hard or interesting, and then I'll let you work on some with your, partner. Alright, so let's look at number A, or letter A. We're to determine if it's exponential growth, decay, or neither. So basically, is it exponential or not, and if it is it growth or decay? So X is the number of times you fold a paper in half, and Y is the number of sections on the paper. So you know what I'm talking about, right? You fold the paper, you get 2 sections. Then you fold it and you got 4 sections and so on. So would you say that's exponential? Yep. Growth or decay? Growth. More times you fold, the more sections you've got. X time in years, Y value of a car. That would be exponential, and only this time it would be decay. X hours worked, Y money earned at a job. That is not exponential, right? That is not exponential. Let's make sure everybody's good with that. It's definitely growth, but it's not exponential growth. Wouldn't that be linear? If you get paid $20 an hour, the more hours you work, the more money you make, if that's a linear relationship. How about the number of people on a Netflix account and the cost per person for the account? You think that's exponential? No. If I have to pay $100 and it's just Quinn and I, then it's $50 each. But what if there's 4 of us on the account? Oh, wait a second. I'm dividing, but I'm not dividing by the same thing. Wouldn't that be, what would that look like? The cost is, the cost per person. So if the cost is $100 and there's 4 of us, it would be 25. If there's 10 of us, it would be 10. If there's 1 of us, it's 100. 2 of us would be 50. Is that geometric? I don't think so either, but now that I look at the numbers, I'm starting to overthink this a little bit. Because you divide by 1, and then by 2, and then by 3, and then by 4 to get the cost per person. So that isn't proportional. No, I think it's neither. I think it's definitely going down, but it's not either one, or it's not exponential. All right, population of 92 fruit flies triples every 2 days. How many fruit flies are there on day 4?
828.
Every 2 days we triple, so wouldn't we need to multiply by 9? Because we're tripling twice. How many fruit flies are there on day 5? Okay, so it triples. We start with 82, 92, and we triple every 2 days. So this is a 2-day period. So what do I need to do? Divide it by 2 to get the per day period. So whatever 92 times 3 to the 5 halves is, would be our answer. And then, so my equation would be this. Does that make sense to everybody? This is like those half-life problems, only it's not a half-life, it's actually tripling. A swimmer wants to qualify for the Olympics. His plan is to reduce his time by 3% each week. Do his swim times for each week of the summer represent an arithmetic sequence?
No.
No, because why? It's going by percentage. right? So each week he's multiplying by 0.97. That's geometric. That's definitely geometric. If he wanted to reduce his time by 1/10 of a second each week, then it would be arithmetic. All right, list the parent function, domain range, and all that for this guy. All right. So we have the equation 3x minus 4 plus 8. The parent function is just the basic exponential, so that would be 3 to the x. That's the parent function. All right, so what have we done to this then? This guy right here, would look like this. That's what the parent function looks like. So it says, what are the transformations? Well, what did we do here? We moved it 4 to the right and up 8. So moving it 4 to the right certainly changes the individual points, but does it change this asymptote if I move to the right? No. How about this though? Does that change my asymptote? Yep. Now it's up here at 8. So this is what my guy looks like now. What's the domain and range of this function? Good problem. What's the domain and range? What's your domain? Negative infinity to infinity. What are your asymptotes? There's only one. What is the equation of your asymptote? Y equals 8. How about a y-intercept? How do we find a y-intercept for this equation? Plug in 0. And if you plug in 0, what do you get? 3 to the negative 4th plus 8. What's 3 to the negative 4th? 1/81. 1/3 to the 4th. So the y-intercept is 8 and 1/81st. All right, this was like Oscar's problem from the other day. Place a check mark next to the functions that are equivalent to this. All right, while I'm writing them down, you start working it out and see what you can come up with. Which functions are the same as that given one? did you come up with? Yeah, I only came up with one. Which one was it?
Fourth one.
This one right here? None of the rest of them matched. Did anybody have a question about that or find any others that did, you think did? Alright, perfect. A sequence has 64 as its 5th term and 125 as its 8th term. So 5th term is 64 and 8th term is 125. Write an explicit rule for the sequence if it's arithmetic. So write a formula for it if it's arithmetic, and then write a formula for it if it's geometric. Okay. All right, so what do you want to do? Xander, sit up, honey. Thank you, Xander.
We can do the thing where we subtract 64 from 125, and then we have 3 in between. So then, yeah, 3, and then you get 61.
Is that right?
Sure.
Now, he's working on arithmetic, right?
Yeah.
Yeah, because if he's working on arithmetic, then he knows that, okay, here's the 5th term, 6th, 7th, 8th term. He knows that he is going to be adding the same number over and over again, well, 3 times. And the total distance is 61. So what would he be adding each time? Well, it would just be 61 divided by 3. So that's his difference. His difference is 61 divided by 3. Now, I went ahead, just because it said write a formula, I went ahead and wrote out my arithmetic formula. What does this stand for in the formula? The first term. Now, this was the 5th term right here. This is term 5. I need to get all the way back to the first term. So I have some options. It wouldn't be that hard to take 64 and subtract 61/3 till I got back there. You can also use the formula itself. So 64 should equal whatever your first term is plus 61/3 times 4. So 4, backing up 4 of those will give you your first term. So what is that? 64 minus 61. I got negative 52/3. Anybody get that? Yeah. I got it twice, so I think it's right. So my formula would be, my nth term would be negative 52/3 plus 61/3 times n minus 1. So negative 52/3 plus 61/3 n minus 61/3. So what is that? Negative 113/3 plus 61/3 n. Clearly not a rigged problem, right? But that's okay, we have a calculator. Everybody okay with that? Now, what if it's geometric? The setup is the same, the given's the same, but what if it's geometric?
The other divide, the 125 by the 64.
We still have a difference of 3 over here, but that 3 doesn't represent 3 additions, it represents 3 multiplications. the multiplication to get from here to here is 125 over 64, right? So r cubed, 3 multiplications, has to be 125 over 64. This one was rigged, luckily. What's the cube root of 125 over 64? 5 over 4? Which means your ratio is 5/4. So when you write your formula, yeah, I don't know what my first term is, but my ratio is 5/4. Now, how could we find our first term? We got options, what do we do?
Same way from the first
Yeah,
one.
we could divide, only I would be subtracting, I would be dividing. So I could take 64 and basically divide it 4 times. So 64, to go back to a sub 1, I could take 64 and divide it by 4 1.25s. Does that work out? It didn't for me. Did you say it didn't? I'm getting 26.2144. So 26.2144 times 1.25 or 5/4 to the n minus first would be your geometric equation. All right? Okay, I'm gonna give you about 10 minutes to work through as many of the rest of them as you can get done. We kind of did half of them together. Work through these next ones, and while you're doing that, I'm gonna hand out some papers, some things for you to have, and I want you working together, and then we'll take the last couple minutes and answer any questions that you have. Okay? You're gonna get 2 things from me, so make sure you do.
36. 1 plus 690. So 43 times 6 is 11.
Are you using the PR? That's the first. We're on K. Or H. I want to challenge.
Yeah, with the robotic.
That one hurts. That one. Hold the picture.
Okay. Well, yes.
All right, have we found any we need to talk about?
Unfortunately, it's got to be this way. Some different speed.
Yeah.
gosh, does K look familiar? We did K earlier in the period, do you remember? Problem K? Yeah, we did. Yeah, we did. For problem G, we're gonna have to get going here, guys. For problem G, you're gonna use this formula for the first one, and this one for the second one. This is problem G. And you're just gonna crank it in on your calculator, and that's how you're gonna get the values, okay? Remember, compounded every 6 months means twice a year, so N is gonna be 2 in that formula. That's your compound interest formula. Which is bigger? So I hope this is a lot of this. To find the common ratio between these two terms, did you divide 1536 by 24 and cube root it? Because there's a 3-term difference between the second and the fifth. And then for arithmetic, you take the difference in the values and divide it by 3 because there's a 3-term difference there. The arithmetic one came out to be a little bit bigger. J, did you notice that J was just arithmetic with a common difference of 6? So I just did my arithmetic formula there. Letter I don't know how many books I had in the beginning, I'll call it A, but I know they're doubling every year, and I'm doing it for 6 years, and I have to end up with this number. Does that look about right? For problem I? All right, what did you do for K? Letter K, I mean. Drew?
I first started by finding like how much the rate of change is changing.
So, how did you do that?
I looked at the points from 2 to negative 2 to negative 1, and it changed by 6.
So, you actually said -2 has a y coordinate of 7.
Yep.
And -1 has a y coordinate of 1. So you looked at a couple of points. Okay, and then, so then what did you do?
I found the slope for that, or rate of change for that,
Okay,
and then
slope is kind of not a good word to use there, but yeah. Okay.
and then I found that was -6.
Okay,
Um,
and then you have 0, -2.
Yep, and then I also used that -1 point again, and that slope was -3.
Okay,
And then I found out that the rate of change was changing by a half.
okay, now, he can get away with that using just 2 points because from the picture, we know this is exponential. If you found 2 random points in the hallway, you would need more than 2 points to figure this out, or 3 points to figure this out. But he figured it out with just these because he knew it was going to be exponential. He also knew it was going to be decay. So it makes sense that his ratio is 1/2 just by analyzing the points in the picture. Okay, then what did you do? You said y equals a times b plus b. Okay. So now you know that b is 1/2.
Yep.
Okay?
And then I looked at the picture to find the horizontal asymptote, which was -5.
So he trusted his picture to tell him that this thing had been dropped down 5. Does that make sense to everybody? And then,
I plugged in 0, -2, and then solved for A.
okay, because if you put in, here we go, let's put in 0 and -2. we don't have time to talk about these other ones, but you are gonna need to do that. Know how to do this. I have given you a review sheet, another review sheet. Your job is to look that over the weekend, and the rest of this one that was gonna get done. And coming Monday, ready to wrap this up, so that on Tuesday, we are going to have our quiz. Okay, got it? Okay, so you have got to invest a little time in this.
You were happy a minute ago, you better be